Hey, hello, this is MD Samir Alam, and today I will talk about a research paper. The title was Enhancing Sleep Disorder Diagnostics with a Machine Learning Approach Using Ensemble Neural Network. The author are MD Samir Alam, Samia Maishajeba, Ankon Devnath, Tanjim Taharat Orpa, and Rifat Siddiqa. And this is a authorship paper by myself. As you can see, the first author is MD Samir Alam. So this is me. So let's talk about how I work in this paper and how the methodology work here. So the first thing is sleep disorder. This is a very important topic right now because our young generation are facing too much problem with this, and the young generation are mainly victim of this disorder. So this is a currently a trending topic right now for our generation. So the main thing is about this paper. This study explored various machine learning techniques to predict sleep disorder, utilizing a comprehensive dataset to enhance diagnostic accuracy. We implement multiple artificial neural network architecture like ANN bagging, ANN boosting, and weighted average ensemble to identify the most effective model. Our results indicate that both the NN bagging ensemble and NN boosting ensemble achieve the highest accuracy, that is 94.7%, followed by closely the NN weighted average ensemble accuracy with 92.9%. So this is a proposed model. Actually, our proposed model was NN bagging ensemble, NN boosting ensemble, and NN weighted average ensemble. So can I highlight this? Yes. Okay. So yeah, let's talk about the introduction part. Uh, sleep is a distinct state of awareness in which there is a reduced engagement with the surroundings and the body's sensory function, and those are really important. Then we can see that the stats that in 2020, in 2005 update of the International Classification of Sleep Disorder, improve on various version by incorporating both symptom based and psychological approach to categorize sleep disorder like this. We can see it here that it organized 81 categories of sleep disorder in as so we basically work with three categories like sleep apnea. We will talk about this later, but as you can see, there is 81 categories. So in this data set there is only three categories. So the classification differentiate between various type of isomania like breathing disorder during sleep, then excessive sleepiness, like that. There are many things. So okay, how can I do this? Okay, as you can see, people typically spend around one third of their living sleeping or resting, because this is very important. We have to sleep at least 8 hours in a day. Then although this is a common expectation, the reality is that 1 out of every three adults does not get sufficient sleep, with many individuals averaging only 6.8 hours per night. As I said before, our young generation face a lot of problem because they go to bed at 2 a.m. or 3 a.m. or 1 a.m. like that, but then they have a class or something in the morning. That's why they cannot have a proper sleep, like 6 hours, 5 hours, sometimes 4 hours for exam, like that. This really like affect our body and our mental situation. So uh, that's why sleep disorder is a very sensitive and issue for us. So let's deep dive to next part, and let's talk about the main five objective of this paper. So the first objective is that implementing ANN technique to forecast the presence of or absence of sleep disorder. So we basically propose a ANN technique, artificial neural network technique, then utilizing the dataset that include lifestyle choice, sleep habit, BMI, and various health indicators. Then analyzing the interaction between various factors affecting sleep quality, and sleep quality, evaluating the performance in a model for accurate prediction and diagnostics for of sleep disorder. Then identifying hidden trends with the data to improve sleep disorder prediction. So okay, on this one you can highlight this. Okay, okay. So those are the our four basically sorry, five our objectives. So let's talk about some related work. So there is a lot of related work around this. They got 70% accuracy. Let's see, this author got 70% accuracy, and like this author, they use SVM model and they got 91.44% accuracy. Also, many author use LSTM, CNN architecture, but they did not get that much accuracy. As you can see, 83%, 81%, like that. So 85% is another, and you can see that on author use in an artificial neural network, but they got assuming only 92.92% accuracy. So this is quite good. That's mean artificial neural network were good in this data set. And you can see that there is another author is also getting 86% accuracy. Okay, so okay, this is the another author. He got 96.10% accuracy. So those are all about the related work. So you can see there are various data sets. So various data set using, they got 94.87% accuracy, like that. So let's talk about our proposed methodology, you know. So okay, first talk about the dataset pre-processing. So in this paper, we have got a dataset from sleep, health, and lifestyle dataset from Kaggle. Generally, the dataset contain many missing value, extreme data point, like that. So we have to address those issues like null value and outlier handling and extreme values, like that. Additionally, we encoding the variables to optimize the performance of the model. Finally, we normalize the data to ensure the model is more effective and predicting outcome. So there is total three category, as I said before, like non isomania and sleep apnea. So those are assigned like 0, 1, and 2 respectively. Like the none for 0, isomania for 1, and sleep apnea for 2. So our proposed architecture is artificial neural network. So as you can see, there is a lot of like hidden layer, and then we got the output layer, and there's input layer, hidden layer, like that. So okay, so input layer, the layer the data is fed into the network with each node corresponding to a feature in the dataset. Then the hidden layer, intermediate layer, that transform the input into a higher level feature. Each hidden layer neuron applies a weight sum of its input followed by an activation function. And output layer, the final layer of output prediction of the transform input from the hidden layers. So let's talk about the bagging ensemble. How we process those bagging ensemble. For bagging ensemble, we aim to reduce the variance and overfitting issue, like that. It involves training multiple NN model into different random subset of training data through a process called bootstrap resampling. Each model learn unique pattern contributing to a more robust ensemble. After training, the prediction of all model are combined using majority voting for classification tags or average for regression tags. So this is how the NN bagging ensemble works. So let's talk about, okay, that is finished. Now let's talk about artificial neural network with boosting ensemble. Okay, so how boosting ensemble work? So the boosting is an iterative ensemble technique designed to reduce bias and enhance accuracy. In ANN boosting, multiple neural network are trained sequentially, with each model focusing on the misclassification example from the previous model. And this accomplished by adjusting the weight of the training sample, giving more emphasis to difficult cases. And the final prediction are made using weighted voting, where contribution of each model is based on its accuracy. So another thing is weighted average ensemble with artificial neural network. So how weighted average work? The weighted average ensemble is a method that combine prediction from multiple ANN model trained on the some tasks, assigning different weight based on each model performance. And after we have talked about this one. So, after independent training on a reasonable data set, the prediction are evaluated. So that's how the ANN boosting works. So we have a another proposed model. As you can see, there is an input layer. Okay, I have to zoom it. Okay, okay. So this is a like you can see the input layer. Okay, I have to further. Okay, that's great. Let's see. Look, this is the input features. As we can see, then we are doing data pre-processing here. Then we this is our first ANN model. You can see this is our first ANN model. This is the first architecture. Then we got 15 ANN model together. Like there is a 15 ANN model together, like 1 to 15. Then we use early stopping here. If the model like lost the accuracy, then it will be stopped. So there is a 50 ANN model. There's combined, we all 50 model combined for ensemble, like boosting, bagging, weighted average. As you can see, those are uh, together make a ensemble model. Then we see a output. So how those actually work, let's see. Okay, let's talk about the model evaluation. Okay, here the model evaluation, we use like accuracy matrices, recall matrices, F1 matrices, then precision, like that. So those are the like accuracy calculation, like equation. Accuracy F1 is for recall, then precision, like that. So let's go to the confusion matrix. Okay, before confusion matrix, let's talk about the uh, how each model actually work. As you can see, this is the uh, basic artificial neural network model. You can see that there's a classification report, like for health, healthy sleep, isomania, sleep apnea. So you can see healthy sleep have a better accuracy rather than isomania and sleep apnea. And recall is also very good. It's 100%, but isomania have a less like recall. This is all about ANN. You can see the all matrices. Let's talk about our like proposed ensemble model. So look, ANN bagging, its precision is same, like FNI's precision is same. And let's talk about boosting. Boosting is also precision is same. ANN weighted average ensemble is also same. But as you can see in isomania, precision is 89% for a normal ANN model, but in ANN bagging it's totally 100%. This is quite good. And in ANN boosting also 97%. It's improved. Then 97%, and you can see 73% for recall, but it's overcome 82%. Here 82%, here 82%. So you can see the visual improvement of our proposed model, ANN bagging, ANN boosting, ANN whatever, because you know there is a 15 ANN model. This is the single ANN model. So there is a 15 ANN model, like 1 2 like that. 15 ANN model, all model are give a prediction, then we make an ensemble, then we got the output. So for this scenario, as you can see the visual improvement, that look, there is 73% recall, but it's improved 82%, 82%, 82%. Let's talk about another thing is like sleep apnea. F1 score is 84%. But look, ANN bagging have F1 score 89% is a good improvement. Also, ANN boosting have a 89% F1 score. F1 score 89% for ANN weighted average also. So this is really good uh, for our proposed ensemble model. So let's talk about the confusion matrix. This is the confusion matrix of the basic ANN model. You can see, and those is the confusion matrix of ensemble ANN bagging model. So this is a confusion matrix, and we have a like a comparison table for how those paper are use the same data set, how they got accuracy and other, yeah, other things. You can see the author 7, they got 70% accuracy, and this author got 91% accuracy, this author got 92% accuracy, 86% accuracy, but we got 94.7% accuracy because we proposed that ensemble model that is quite good, as I explained before, how is matrices improve compared to normal ANN model and our proposed ensemble model. So this is the confusion matrix of the ANN boosting model and ANN weighted average model. So let's talk about the feature importance. Feature importance, like how is feature like how is feature uh, contribute the output. Look, the feature importance, blood pressure have the higher impact on our result, and then BMI category, age, sleep duration, physical activity level, then daily step, heart rate, quality sleep, stress level, and gender. So you can see the blood pressure, BMI category, sleep duration, and age. Those four features are very important for sleep disorder prediction. So as you can see, the evaluation matrix defined model, there is a bar diagram. Let's zoom it. Okay, zoom. Yes, yes. Look here, accuracy is the green color, and microphone score, and also the macrophone score. You can see the ANN model accuracy and ANN bagging model accuracy. This is a really good improvement. Like look at this bar diagram. We got a good improvement for ANN bagging ensemble and ANN boosting ensemble compared to ANN model and ANN weighted average model. So this is good. Also the macrophone score and microphone score is also improved. uh, so the macrophone score is very low compared to other ensemble model for ANN model. So this is good, that our proposed model handle really good. uh, then let's zoom it out. Okay, so this is the result part. As you can as I said before, that ANN bagging ensemble and ANN boosting ensemble have an impressive accuracy 94%, showcasing a significant improvement over the baseline ANN model. The macrophone score ensemble model are 92.4% and 91.3% respectively, and indicating their ability to manage class imbalance effectively while maintaining high precision. So if you like, let's just normally think about this, like we we are working with one ANN model, but in ensemble model we are working with 50 ANN model. So this is really good to improve your accuracy and make your model robust and strongly efficient for a healthcare system. So this proposed model, like ANN bagging or ANN boosting or ANN weighting average order, so those are really good, and those are perfectly work in this data set. I think in every dataset it may be work. So let's talk about the single matrices. You can see that ANN model accuracy is 89%, 89%, and bagging has a 94.7%, also boosting at 94.7%. After fine tuning, you can see that 92%. Oh, this is another matrices for this model, but those two model, ANN bagging and ANN boosting, those are really efficient. Those are outperform basic ANN model and ANN weighted average ensemble model. So you can see that the visual improvement 85% to 92%, 91% to 94%, 91% to 94%. So all matrices are improved for those bagging ensemble and boosting ensemble. But bagging ensemble is outperforming a boosting ensemble. Bagging ensemble has better matrices record rather than boosting ensemble. As you can see, for macro F1 score 92%, and F1 score is also very really close, 94.6%, 94.5%. But in macro F1 score, just too good. Bagging ensemble 92.4%, but boosting ensemble only 91.3%. But so ANN bagging ensemble is superior than other all ANN model. So ANN bagging ensemble is the proposed model. So those are the reference for this paper, and let's talk about the conclusion. Sleep disorder is such as insomnia and sleep apnea pose significant health risks affecting both physical and mental well-being. So we have to fix these issues. So the baseline ANN model achieved strong result with accuracy of 89%, but application of ensemble method like ANN bagging and ANN boosting significantly improve performance, rising accuracy of 94.7%. As I said before, those are really quite good. So this is all about this paper. So you can simply go download it and read it, and also work with this data set. You can search it by like this, like sleep disorder neural network, and you can find it here, the first paper, ACM Digital Library. So here you can read the paper. As you can see, 130 1387 people downloaded this paper. So this is really a impactful paper. So you can read it here, read it from here. This is a website. So that's all about today. We will discuss about another paper in next video. Thank you everyone.